This reference design is for making an RGB Matrix display product. It includes everything from schematics to assembly instructions and firmware to behavior control.
Rollout. We share hardware reference designs for robotics so you can make your own hardware.
Hi there, welcome to Rollout. I'm Jeremy, and today we're rolling out the E-19 RGB 8x8 display. These are some of the features of the RGB 8x8 display. It has 64 bright and colorful LED pixels. The green is actually a nice bright green compared to most displays. It can display robot emotions. It can create a scrolling marquee message. You can create games as well. And you can also adjust the I2C address so you can control multiple displays. Okay, let's connect the RGB 8x8 display to EasyBuilder. Let's start with an EasyBuilder compatible board. I'm going to use the IoTiny. Connect that up. Next, we'll connect the display to the I2C port here. And you'll notice that it displays its I2C address on there, 162. And that correlates to hex value A0, or A2 actually. Okay. Go over here, we'll connect to the Wi-Fi address. And then in EasyBuilder, we'll hit connect. There we go. Next, we'll add the behavior control for this display, which is the RGB 8x8 animator. We'll hit the settings button. We'll have to add a new action here. We'll call it happy. Hit OK. We'll also have to add a new frame. And then we can start creating our happy face here. And nothing will appear until we actually select what color we want. And there you'll see it come up. So, do a smile. There we go. You can mix the colors. All the colors mixed as white. There we go. And if we add another frame, we can actually make a... Actually, let's remove this frame and duplicate this frame and change it up a little. So if we select all these and then take away the colors, we'll actually make it black, and so that they won't display. Then if we hit unselect all, we can make something different. Let's make a wider smile. And then we'll select red and blue as well. Okay, and we can put this action repeats, and we'll take the pause down, the pause between these frames, so down to 250. There we go. Save that. And then if we select it and hit execute, we'll have our happy animation there. So to save some time, I've loaded in some animations that I previously made, and I'll show you what I've done to create them. So we go into the settings here and I select marquee. You can see all these frames that I created to create the message hello, and that can scroll across the display. So I'll just close that and I'll execute hello. There we go. You can change the speed as well if you change the pause between the frames. Okay, I'll show you a different animation that I created called Space Invaders. And this you can actually make some sort of game if you'd like. So this animation scrolls through and it has this little ship shoot the little pixelated Space Invaders. So get out of here and then I'll execute that for you. There we go. So you can control the different pixels on the display with script commands if you'd like, and then you could create a game. So let's go behind the scenes and look at the schematic for this display. Okay, here's the schematic. And first off, you'll see that It's pretty crazy to look at this section here. This just represents the RGB matrix itself. So you can see all the RGB LEDs in each element, all 64 of them. And the control lines there. And then over here is the common lines for all those RGB LEDs, and they're hooked up to all these P-channel MOSFETs. And so these are the two headers that attach to the display. I think it's 16 connections, it looks like, per side. And here's the microcontroller that controls the display. It's a PIC 16F 1937. We have all of our select lines all connected from here to the display. And we have our headers. There's a programming port that's not populated, and then our I2C header port. Here's the bill of materials, and you'll see that the first element is the PCB, and the second is another PCB. You don't actually need the second PCB if you're not connecting to the Easy Robot system. Then we have the microcontroller itself. Then we have the actual JST connector that connects the display to the iTiny. We have our 8 P-channel MOSFETs. It's important that it's a low capacitance gate. You don't want to have bleeding of colors, so choose a low capacitance P-channel. And then we have our capacitors and resistors. And you don't need this header actually if you're not going to use the Easy Clip, because that header is what connects the Easy Clip to the display board. And lastly, you have the display. It's important to get the version that has the GG on there. And that's actually the bright green LED version of that display. And so it's just a lot better if you get those types of displays, because they're just much more clear and brighter, and it just makes the display pop. And that foam tape is also optional. It only goes on top of the PIC chip if you're using that second Easy Clip PCB. Last thing to note is that the chip does need custom firmware, and we include that in our GitHub reference files. Here are the assembly instructions for the display. As you see, the first portion here is mostly to do with attaching the Easy Clip header, so that's optional. Then we'll scroll down, and you can see that the orientation is important. You can mess this up if you don't pay attention to where the dot meets up with the writing on the display. So solder that all together, and that's complete. That was the E-19 RGB 8x8 display reference design. Find the links for the Synthiam behavior controls and the GitHub reference design files in the description box below. And don't forget to subscribe to get notifications for new rollout videos. Over and out.
Thank you for watching Rollout. For more information, visit www.synthiam.com.